What is the limiting reactant of 200 milliliters of a 0.2 molar solution of iron 3 chloride is reacted with 175 milliliters of a 0.325 molar solution of magnesium hydroxide? A limiting reactant problem that we already learned. We're going to have to deal with moles on this. We don't have to worry about grams at all. And the key to solving this problem is remembering that molarity times volume, if you have liters, is equal to moles. Okay, so we can do that. We can also use milliliters. Molarity times volume in milliliters is going to give you millimoles. Either one works. I think I'm going to use the millimoles to keep the math simpler. As far as our conversion factors go, either one will work fine. But before we can do anything, we need to balance the chemical equation to make sure we get the proper stoichiometry relationship between the two reactants. We're reacting iron 3 chloride, so we have FeCl3, and that's aqueous. We're reacting that with magnesium hydroxide, MgOH2, aqueous. And this is a metathesis reaction, of course, which is going to form magnesium chloride, MgCl2, and our other product, of course, is going to be iron 3 hydroxide, FeOH3, and that's a solid. So now we need to balance the equation, and we notice we have a bunch of 3's and 2's here as our subscripts. Our hydroxide being a polyatomic anion, we want to keep that as a single entity, package deal. I've got 2 on this side, 3 on that side, so we're just going to put a 2 in front of this, and we're going to put a 3 in front of that, and that's going to take care of that. Chloride's the same thing. I got 2 chlorides here, 3 chlorides here. Let's put a 2 in front of that. Let's put a 3 in front of that. We're balanced. Since this is a limiting reactant problem only, they're not asking us at all to calculate anything about the products. Let's now ignore the products. No longer applicable to the problem. We now can calculate the number of millimoles of our iron chloride and our magnesium hydroxide. So to do that, we are simply going to take the molarity. Let's do the iron chloride first. So let's just write the numbers right underneath here. So for iron chloride, we have 200 milliliters, and we're going to multiply that times a concentration of 0.200 molar, and that's moles per liter. So when we multiply that together, we're going to get 40.0 millimoles. Let's now do the same for our magnesium hydroxide. Here we are told we have 175 milliliters. We're going to multiply that by its concentration of 0.325 molar. Doing the math on that, we get 56.9 millimoles. Okay, now we cannot at this point say that iron chloride is our limiting reactant because that's a smaller number. We have to look at the stoichiometry between the two reactants. It's not the same. It's a 2 and a 3. So again, we're going to have to make our assumption, our premise. Let's assume that iron chloride is the limiting reactant. Make that assumption. Then the question is, how many millimoles of magnesium hydroxide do I need to react with all of my iron chloride? Because all my iron chloride, if it is a limiting reactant, must be consumed. Limiting reactants are always consumed in a chemical reaction. If I don't have enough magnesium hydroxide to consume all my iron chloride, then iron chloride cannot be my limiting reactant, and by default then magnesium hydroxide would be. So we're going to do this in our usual stoichiometry calculation. Our starting point here now, since we are assuming that iron chloride is our limiting reactant, is the number of millimoles of iron chloride. So we're going to start with our 40.0 millimoles of iron chloride. We want to know how many millimoles of magnesium hydroxide do we need. Well, first thing we're going to do, since we already have millimoles, we're going to use the coefficients to now convert that to millimoles of magnesium hydroxide. It's a very simple calculation. 3 moles of, or millimoles of magnesium hydroxide are required for every 2 millimoles of iron chloride that reacts. So I'm going to multiply that by 3 millimoles of magnesium hydroxide are needed for every 2 millimoles of iron 3 chloride that's going to react. So my millimoles of iron 3 chloride cancel. My 2 does not. So I multiply 40 times 1.5, which is going to give me 60.0 millimoles of magnesium hydroxide. Let me scroll up. Needed. That's how much I need of magnesium hydroxide. Looking back at how much we calculated, we don't have that much. We only got 56.9 millimoles. So we do not have the minimum amount required, 60. Therefore, our premise or assumption is wrong. Iron 3 chloride is not the limiting reagent, and by default then magnesium hydroxide is the limiting reactant.